So what I'm going to do today is go over and review what we've been doing in the first 7 ILEs. So we've been looking at position time graphs and velocity time graphs and going between the two. And what I want to do is review that and then show you a few little tricks for thinking about it, that is, analyzing the problem. And I'll start by drawing a couple of axes.
So first of all is our position time graph, and below it I'm going to draw a velocity time graph.
And we use plus and minus as meaning away and towards our point of reference, which in this case would be our ultrasonic motion detectors. So, if I wanted something that was going away, I would want the position to go from close to the reference point further away, right? So something like that is indicating that I'm going away. I'll do away here. If I want to do something towards, it's going to be like that. Right? Because the position I started at is further away than the position I end at. And if I want to show that I'm not moving at all, what I need to do is say, okay, if I'm not moving at all, my position does not change. That means that I'm going to have a horizontal straight line. Okay? All right, so now let's look at what velocity time looks like. This region here, right, that's the positive region, and therefore anything that's going away, right, for the velocity time. This one here, that's a negative velocity. It means that it's anything in the towards region, right? So we call this the toward region. Notice how I've suddenly broken up the velocity time graph into 2 bits, right? One for positive slopes and one for negative slopes. Because after all, the slope of the position time graph is, by definition, the velocity. The slope of the position time graph is the velocity. So we can say the rate of change of position with time, which is slope, is velocity. So by looking at the slope in any particular point in the position time graph, we can plot something in the velocity time graph. There. What can you tell me about the motion of this object whose position time graph looks like that? Yes?
It's moving at a constant speed.
It's moving at a constant speed. What else can you tell me? Someone else? Yeah?
It's moving away.
It's moving away. Constant speed away. Okay. We know that this is the away region, right? So we know that the velocity, because the slope is not changing, must be in the away region, and it must be constant. That is, it doesn't change. This is one value for the velocity, which is the same all the time. If we had a slope which was not so steep, what can you now, someone else, what can you now tell me about the motion of this object? Julia. So
Oh, that one's slow. Or than the other one, sorry.
it's slower than the other one, yeah. What else can you tell me?
It's moving away.
Yes, and what else can you tell me? there are three things that you can tell me about this. One is it's slower than this one. The other thing is it's moving away. What else can you tell me about it?
Oh, it's constant.
It's constant, right. So it's constant, it's moving away, and it's smaller than this one. So what it would look like then is that. Okay, let's have a look at a different one. Let's have a look at this one. Someone else. What is this doing? What is the motion of this one? Yeah?
It's going towards,
Yeah?
and it's constant,
Yeah?
and it's like kind of fast, but not that.
It's kind of fast, not really that fast. So what am I going to draw down here?
A straight line going like around the middle,
So, and a straight line, you mean a straight
Like-
line?
flat,
Horizontal.
horizontal.
Yeah, horizontal, straight line, like that. Yes. That's what I would do. All right. What if instead I had that line? All right, so there are three things you can tell me about it, just like Julia could tell me three things. You're going to be looking at what? The slope, right? Because that's what we need to know about for velocity. Can you tell me, is that slope changing or not?
No, it's constant.
So the first thing you can tell me is the velocity is constant, right? What's the next thing you can tell me?
It's moving fast.
Faster,
Faster than the other one.
faster than this one. Okay, and what's the third thing you can tell me? Towards the origin, right?
Yeah.
So it's not moving away, it's moving towards. So there are three things: constant, towards, and faster than the previous one. So if it's faster than the previous one, how do I draw that here? Lower, exactly. Because unlike a number line in math, in physics, a bigger negative number is actually bigger. The smallest number is 0 because the minus sign is just indicating a direction. I could change this to say a positive velocity means a velocity going north. A negative velocity means a velocity going south, right?